Hey class, a few people have been asking me about problem 20 on the homework, so I thought I'd give you guys a hint video to help you get started. So this problem is asking us to determine the ratio of the approximate E field from a dipole versus the actual E field from a dipole. So the equation that the problem gives you for the approximate E field is shown here as being 1 over 2 pi epsilon naught multiplied by Q times d over z cubed. And I wanted to first start by showing you that this is actually the same approximate E field that we derived in class, equal to k times 4qa over x cubed. First off, as you can probably deduce, is they just defined x as being equal to z. They just gave it a different letter name, but it's the same idea. The other thing to keep in mind is we defined a as being the distance from the center of the dipole to one of the charges, whereas the book is using the value d, which we mentioned in class as well, which is the dipole separation. And so from that we can determine that d is just going to be equal to 2 times a. So if we substitute in x and d into our equation here, then we should be able to observe that our equation, E approximate, is just going to be equal to, I'm going to pull out the 2 that's left over, 2k multiplied by q d over z cubed. Alright, and then 2k, you can observe, is actually going to be equal to 1 over 2 pi epsilon naught. And the reason for that is because k is defined as being equal to 1 divided by 4 pi epsilon 0. So now that we established that the approximate E field value that they give you is the same as what we derived in class, I now want to help you determine what the actual E field would be. So if you recall or look at the PowerPoint slides, we derived what the actual E field would be in class up to this point, after which point I did a few things on the board to help you see how we could get the approximate value from this. So I'm going to start from here and help you out a little bit in determining what this looks like, or what this might be equal to, in a format that will help you determine the ratio of these two E field values. So what you can do is you can try to join or add these two fractions together by finding the common denominator. So if we do that, this E field is going to be equal to, we keep the kq over x squared out here, and it's going to become equal to 1 plus epsilon squared minus 1 minus epsilon quantity squared divided by the common denominator, which would be the product of those two, 1 minus epsilon squared multiplied by 1 plus epsilon squared. So, put my parenthesis in the wrong place here. Okay, so from here you can factor out the top, and when you factor it out and multiply everything out, you should find that the top up here has a value of 4 epsilon, and that's all. And then with the bottom, you can actually use an identity, or you can factor it out as well, but the identity tells us that a squared minus b squared is equal to a minus b multiplied by a plus b. And so basically this a minus b multiplied by a plus b is what we have on the bottom, just that quantity squared. So what we can say that this bottom is equal to is going to be, let me draw kind of an arrow down here, the product of these two comes out to just be equal to 1 minus epsilon squared. Technically, as we see up here, it's 1 squared, but 1 squared is 1. And since we have it twice, it's squared. So this entire E field can be rewritten as being equal to kq over x squared multiplied by 4 epsilon divided by 1 minus epsilon squared quantity squared. Okay, so now if you recall in class that epsilon is just equal to a over x, and you can go ahead and make the substitutions that we did earlier, where we know 2a equals d and x is just equal to z. You should be able to plug all of these things in to this beautiful equation we have here and divide your two E fields, as we see up here, the approximate E field divided by the actual E field to determine the ratio. So go ahead and give that a shot. If you have any questions, let me know. But hopefully you should be able to get something that reduces quite easily. A lot of the things we don't know, like K and Q, will end up canceling out with one another, as well as I believe Z, and you should be able to get a nice solvable problem. Or sorry, excuse me, Z does not cancel out. Z was given to you in the problem statement. Anyway, good luck. Let me know if you have any questions.